In this video, we are going to solve Irodov 1.60. So let us start. The given problem is as follows. We are given three mass M0, M1 and M2. They are attached to each other by two different strings. Let's call this string as some L1 and call this string as L2. And let's say the stress in this string is T2 and stress in this string is T1. Now we are given situation that this whole system of these three masses is accelerating downward with an acceleration W. So we need to find, and we are asked to find the value of T1 and the value of acceleration in terms of M1, M2, M0 and G. So let us start the problem. So before we start the problem, let us make the free body diagram of mass M0, M1 and M2. So let's start with the free body diagram of mass M0. The force acting on M0 is T2, which is in the upward direction because of the stress in the string, and force equals to M0 times G is acting on it in the downward direction. Similarly, if we make the free body diagram of mass M1, this would look something like this. So since this mass M1 is lying on this surface, so there is because of the gravitation there is a downward force acting on it, which is equals to the mass of the body times acceleration due to gravity m1g. Because of the Newton's second law, an equal and opposite force is acting on m1 in the upward direction, which is called the normal reaction, which we are representing here by R. The string is acting and force on this in this direction, which is equals to T2. Similarly, this string is acting a force on it in this direction, which is T1. And because of the finite friction between the surface and the mass M1, there is a frictional force acting on M1, which is equals to K. Here K is the frictional coefficient between the mass and body times R. And since there is no motion in the vertical plane, so R will be equals to M1G. So the frictional force acting on mass M1 equals to K M1G. Similarly, the free body diagram of mass M2, the same gravitational force is acting on this, and the surface force, the normal reaction force due to the surface is in the upward direction. The string over here is exerting a force T1 in this direction, and the frictional force is acting on it in this direction. So now we are given that the entire system accelerates towards the earth or in downward direction with an acceleration W. So let us write the equation of motion of all three masses. So since this is accelerating towards earth or in downward direction, so the equation of motion for this will be m0 g minus T2 equals to m0 g. Similarly, the equation of motion of m1 will be T2 minus T1 minus k times m1g equals to m1w, and equation of motion for mass m2 will be T1 minus k times m2g equals to m2g. So now here we have got three equations. Let us call this equation as equation number 1 and equation number 2 and equation number 3. So now we'll solve these three equations to find the value of W and the value of T1. So let us go to the next page and write all these three equations together. So here we got our equations. This is our equation number 1, equation number 2, equation number 3. So let us solve these three equations to find the value of W. So if we add all three equations, T2 here will get cancelled with this T2 and T1 here will get cancelled with this T1. So on the left hand side will remain with m0 g minus k times m1 g minus k times m2 g. On the right hand side we'll have m0 w, m1 w and m2 w. So if we take g common on the left hand side, here we'll get only m0, so this m0 will come here. Here k times with k times m0 with a negative sign, and similarly k times m2 with a negative sign times g. And on right hand side if we take w common, we'll get m0 m1 m2 times w. So now is just simply we divide this expression by this and we get the expression for w, which is this. Now if we again take these two equations, only these two equations, and add both the equations, T2 here and T2 here will cancel each other, but T1 will remain, and the resultant equation which we will get will be m0 g minus T1 g, m0 g minus T1 minus k m1 g equals to m0 m1 times omega times w. The value of the w we have already found in, say, call this equation 4. So if we put the value of the w in this equation from this expression and do some simple mathematical manipulations, we get the following result. This is the desired value of T1. So we were supposed to find the value of W, which we have found in equation 4, and the value of T1, which we are having in equation number 5. Thank you. Sorry.